continue from the previous video. Now this is the last video for solving these examples, where we calculate the I effective for the mid span and also I effective at the support. So what happens here at the start, we found the centroid of these without reinforcement. We just take the geometry and we found the centroid of this cross section. Then we calculate the I value taking the geometry, which is the uncrack moment of inertia. Then we calculate the I effective at the mid span, we calculate the I effective at the support. After that, calculating I effective at the mid span and after I effective at supports, we are using this clause 8.5.3.1, where it says that for continuous beam, we are taking this one as a continuous beam. This is continuous beam. It's not continuous, but it's can be classified as a continuous beam. So in that continuous beam, this is N span. I think this is, if you are looking from this side or this side, it will consider as a N span. Half at the mid span, so I effective half at the mid span plus half at the support. So it's plus half at the support. That is the I effective for this beam. So I effective here plus I effective here, half value will give me the I effective value for that beam. So we can substitute I effective at the mid span. I think in the previous video we calculate this I effective at the mid span. That's so on here 9023.4 times 10 raised to minus 6. That's we calculated I effective at the mid span. That's I substitute here plus half times 1.05. We calculated this I effective at the supports. I can show it to here. In the last video we calculated I effective at the support 1.05 times 10 raised to power 10, and this half is coming from, it's basically average coming from half here, and there is another half here, so and this plus. So if you just use the calculators, you can get 9.8 times 10 raised to minus 9 millimeter power 4. Now short-term deflections, if you are taking these prop cantilevers and if you're looking for maximum deflection somewhere here, that will not be at the that deflection that you can calculate at WL to the power 4 184 EI. Now the calculation of this is short-term deflection. So due to the short-term loading, which is 88, so if you can see this in our calculations, where we calculate the serviceability load, where we calculate the short-term loading, which was 88 kilonewton per meter. So I substitute this 88 kilonewton per meter times the length of this beam is 9000 given in the questions. I can show it to you here in the figure. It's given 9 meters, so I just converted into the millimeter to the power 4 184. Please note this Young modulus is the Young modulus of the concrete that is given in the questions. EC was given 30,100 times I effective that we just calculated for the whole beam, which is 9.8 times 10 raised to 9. That's give me 10.6 millimeters. That is the short-term deflections, immediate deflections. The beam will subjected to this dead load, and due to this dead load there has an immediate deflection 10.6 millimeters. Now long-term deflections over the period, that is due to the sustained load. Okay, the sustained load applied onto the beam, that sustained load will have an effect as well. So what is the long-term deflection? That considered as a total deflection, the short-term deflection plus due to the sustained loading. Now that sustained loading is your live load. That if you that is long-term load. That long-term load we calculated in the long ago in the video 76 kilonewton per meters. So that I substitute here 76 kilonewton per meter times 9,000 to the power n over 185 times 30,000 Young modulus plus I effective that we calculated here. Now you wondering that we are working in the millimeters, how come we putting this 76? So 76 kilonewton per meters is basically you are 76,000, that is in the newtons over 1000, so that will convert into newton per millimeters. Okay, so therefore we are using 76, and here this 88 is newton per millimeter, so therefore we use this notation, which is 9.1 millimeters. Now there is a creep and shrinkage factors that we need to multiply to calculate a total deflections on the long term. So KCS is given over the page. So if you turn it few page over, and there is a clause called 8.5.3.2, which is long term deflections. They have given this KCS. KCS is named as creep and shrinkage factors. and at midspan we calculate KCS is equal to this value 2 take away 1.2 ASC over AST greater than 0.5. So KCS is equal to 2 take away 1.2. The ASC value is given here, ASC at the midspan. So ASC was 2710 and the tensile reinforcement was 3720. And if you substitute that value, you get 1.3, which is greater than 0.8. We need to check is greater than 0.8, so therefore it's okay. So the total deflection is 10.6 plus 1.3 times 9.1 is equal to 22.4 millimeters. So that is the total deflection here on this prop cantilever. Thank you very much.